My name is Haris, and today we're going to talk about golf.
Driving, pitching, or putting. Golfers know getting just the right amount of force or speed on the ball can be the difference between pulling off the shot or not. When they do interact, it's easy to see that the force of the golf club affects the ball. What's not so obvious is that the golf ball applies that same force toward the club.
During the impact, as the club's applying force to the ball is pushing back with an equal and opposite force. And that would be a good illustration of Newton's third law.
Newton's third law of motion says that forces act in pairs, equal in size and opposite in direction.
Force is really any push or pull on an object. It has a direction and it has a magnitude.
Force is measured in units called newtons. Say the collision applies 8,000 newtons or 1,800 pounds of force to the ball in this direction. The ball applies the same 8,000 newtons of force back to the club in the opposite direction.
And so during that collision, as the moving club contacts that ball, there's going to be an interaction of forces between the club and the ball.
In a collision, the impulse, the force times how much time the force is applied, will cause the object to speed up or slow down. If the club applies a force of 8,000 newtons for 500 microseconds on a ball with a mass of 0.046 kilograms, then the ball will be moving at 87 meters per second after the collision. The ball applies a force of 8,000 newtons back to the club for the same 500 microseconds. But the club has more mass than the ball, so the club's speed doesn't change as much, slowing down only about 13 meters per second. The impulse causes and is equal to the change in momentum.
Momentum is really defined as the mass of an object times its velocity. Momentum is most clearly seen during an impact where the momentum of the club is transferred into momentum in the ball.
This transfer of momentum from one object to another is a principle of physics known as the law of conservation of momentum, which says that the total momentum before the impact must be equal to the total momentum after the impact. The ball gains momentum because the club pushes on it, and the club loses momentum because the ball pushes back.
The weight and mass of the club and or ball will determine how much momentum is transferred to the ball.
Before a club and ball collide, each has a certain momentum. The mass of each multiplied by its velocity. With impact, both have a change in momentum, which is equal to mass multiplied by change in velocity. The ball gains and the club loses 4 kilogram meters per second of momentum.
the conclusion.